This disease's progression can be classified into 3 stages. The prodromal stage can last from months to several years, during which one can experience infrequent seizures or mild hemiparesis, which is a weakness of one side of the body. The acute stage mostly presents near the onset of the disease and is characterized by frequent unilateral seizures and rapid neurological deterioration, such as hemianopia, which is loss of half of the visual field, cortical sensory loss, motor deficit, memory and attention deficits, and learning disorders. The final stage, also called residual stage, features a high degree of neurological deficit, but with a decrease in frequency of seizure attacks. It is noted to be that Rasmussens encephalitis is largely sporadic with no evidence of genetic component. Rasmussens encephalitis is thought to be an autoimmune pathology. However, the exact mechanisms behind the pathophysiology of this disease is largely unknown. We will go through 3 main theories. First of all, cytotoxic T lymphocytes are thought to play a major role in the pathogenesis of Rasmussens encephalitis, with most of the inflammatory T cells being CD8 positive. The invasion of lymphocytic cells is due to the damage of the blood-brain barrier caused by focal chronic unilateral inflammation of the leptomeninges, specifically the arachnoid and pia mater. These lymphocytic cells were found to be in apposition to neurons and astrocytes. They are known to create microglial nodules, and via the release of granzyme B, they cause neuronal cell death, hence neuronal atrophy. Also, through the release of glial fibrillary acidic protein, they alter the activity of astrocytes. This results in an increase in glutamate at neuronal synapses, referred to as excitotoxicity. This is thought to contribute to the onset of seizures. It is unclear as to how these lymphocytes are activated. However, due to their antigenic T cell precursor origin, it is thought that they may express specific antigens to the brain. It therefore has been suggested that the mechanism may be either autoimmune or in response to foreign antigens such as viruses. In the next theory, current research is focused primarily on the involvement of autoimmune antibodies in the pathophysiology of Rasmussens encephalitis. It has been shown that autoantibodies may target specific receptors, such as GLUR3 or NMDA, on the body's own cells, potentially contributing to the onset focal seizures and brain ischemia. This is, however, thought to be a secondary mechanism within the pathophysiology rather than a causative function. The exact role of the central nervous system autoantibodies in the pathogenesis of Rasmussens encephalitis is still unclear. Another mechanism thought to be involved in the initiation of seizures is microglial activation. The immunological process by which these are activated is currently unknown. However, we do know that once activated, they release a number of pro-inflammatory cytokines such as interleukin 1, 10, and TNF-alpha. These are associated with the degeneration of neurons and the progression of epileptic attacks. It is also thought that the release of albumin from astrocytes may alter the buffering capacity of extracellular potassium and NMDA through the disruption of potassium flow into neurons. This will have an effect on neuronal excitability, potentially emphasizing seizure progression.